from document-based systems engineering to model-based systems engineering. So let's see what INCOSYS, so the International Council of Systems Engineering, has to say to model-based systems engineering. INCOSYS defines model-based systems engineering as the formalized application of modeling to support system requirements, design, analysis, verification and validation activities, beginning in the conceptual design phase and continuing throughout the development and also later lifecycle phases. So the focus is to use formalized models instead of documents for the development of systems, to use models in several phases of the development as well as for later lifecycle phases. But some of you might ask, what does this mean? So is it just replacing documents with models and the use of systems engineering principles, or is it more? So let's have a look at that. When developing a new system, it's all about finding solutions to challenges and problems that occur on the way. For that, the framework of processes, methods, organization, and tools is used. There is the development process structured into several phases. Methods such as CAD or EE circuit design, engineers who apply these methods with or without specific tools. Mechatronic system development, for example, requires the involvement of several disciplines who are typically not trained to work together. The result is normally a total chaos and a weak development system. Systems engineering provides fundamental principles and best practices such as systems thinking that should be integrated in and applied in the development approach. In order to focus on the system as a whole, the systems engineer is positioned in parallel to the other engineers to ensure that the system meets all the customer needs. In addition, systems engineering provides principles to structure and connect the different work product of the engineers. Furthermore, holistic system consideration and traceability are essential parts of systems engineering. Now, with model-based systems engineering, these principles and best practices have to be done model-based. But how is this done? One way to start with model-based systems engineering is to create a system architecture and to work with this system architecture in the entire development process. To meet the fundamental principles of systems engineering, the interdisciplinary way of working, a systems engineer creates this system architecture model that integrates the views of various specific disciplines. For the development of a new system, many different models are used. Some are more detailed, some more specific, others maybe more abstract. Some focus on the view from one discipline, others focus on the integration of views from several different disciplines. So there's a big variety. Some focus on the structural or behavioral description of the system, and others on both. All those models can be visualized in the cube, which you see in the center of this slide. A system architecture model, for example, created with Capella, provides an extensive view on the system, includes the views of various disciplines and domains, but lacks in discipline-specific details. A system architecture in context of model-based systems engineering is typically represented via block diagrams and describes the system from a structural and a behavioral point of view. To create a system architecture, a modeling language such as the Capella language or SysML, and a method such as Arcadia, and a tool such as the Capella modeling tool are required. Okay, now we have the system architecture, and this system architecture can now be used as a base for discussion with customer and stakeholders. Especially the alignment of interfaces and the required system functionality are in focus. For the development of the system, the architecture is used as collaboration for the development team and also as an input for the discipline-specific development. So creating the system architecture early in the development process provides benefits in improving the system understanding, discussing the system structure and behavior intensively, identify possible failures and risks, and document all the generated knowledge. When the system architecture is created, it is used as a source of information and the derivation of, for example, test cases. Having at least one model that focuses on the entire system instead of specific details is beneficial in getting and keeping the overall overview, managing the engineers, and much more.